Imagine handing an AI a simple task. Install a Python package, then run a script. Sounds straightforward, right? But here's the twist. You're not giving it a GUI. No buttons. No menus. Just a terminal. A command line interface. Pure text. No safety nets. And when the AI tries, does it succeed? Or does it crash into a wall of error messages, lost, confused, and failing at the most basic things? Well, researchers recently put 18 different AI models, from GPT-5 to Claude, Gemini, Grok, and open-source powerhouses like Qwen and GLM, through a real-world test, Terminal Bench 2. Today, we're diving deep into what went wrong, why it matters, and most importantly, which AI actually knows how to use a terminal like a pro. At the heart of this experiment is an AI agent called Terminus 2, a minimalist, autonomous assistant built to operate in a real, containerized Linux environment. It doesn't have access to special tools, file editors, or built-in APIs. It only gets one thing, a command line interface. Want to create a file? It can echo hello into it. Need to edit code? It launches Vim or Nano. Want to install a dependency? It runs pip install. It's not magic. It's not hallucination. It's execution. And its entire success depends on one thing, the ability to understand the terminal and avoid the thousands of ways a command can fail. So what kind of failures did they hit? The researchers didn't just record success or failure. They built a detailed taxonomy of failure modes, a map of every way a command can go wrong in a real environment. Let's break down the most common ones. Command not found. The AI typed sudo apt-get install Python 3, but apt-get wasn't installed because the system wasn't set up with the right package manager. File not found. It tried to run /script py, but the file didn't exist because it forgot to touch it first. Segmentation fault. The AI generated code that compiled fine, but crashed at runtime due to a memory access violation. Permission denied. It tried to write to /us or /bin, a protected system directory, a classic rookie mistake. Shell syntax error. It typed echo hello, missing the closing quote, which broke the entire command. Invalid format. It tried to parse a JSON file that was actually corrupted, and the parser failed silently. Resource exhaustion. It ran an infinite loop that consumed all available memory, crashing the container. These aren't edge cases. These are the daily realities of working in a real terminal. Now here's where it gets fascinating. Take GPT-5 Codex, the top performer, with a 44% success rate. But even so, 39% of its failures were due to invocation issues, wrong flags, missing arguments, or incorrect syntax. It knew what to do, but failed to execute it correctly. Then there's Claude Sonnet 4.5, also strong at 43% success, but its biggest problem. Runtime crashes. It would generate code that ran fine, until it segfaulted halfway through, often due to unsafe memory access or unhandled exceptions. And then there's GPT-5 Nano, the most verbose model, generating 60,000 tokens per task. It talked endlessly, but it only succeeded 8% of the time. That's the key takeaway. More words not equal to better results. This is a huge lesson for AI development. You might think, just make the model talk more, it'll be smarter. But the data says otherwise. The best models, GPT-5, Claude Sonnet, and GPT-5 Codex, aren't the loudest. They're the most focused. They generate fewer tokens, use fewer commands, and make fewer mistakes. They don't try harder. They think smarter. They plan their steps. They anticipate errors. They verify before acting. Another mind-blowing insight. The number of attempts doesn't matter. They measured how many rounds, or episodes, each model took to solve a task from 7 to 35. But the correlation between number of tries and success rate? Nearly zero. That means a model that fails 20 times isn't more likely to succeed than one that fails 5 times. More attempts don't fix bad reasoning. Success isn't about persistence. It's about decision quality, the ability to choose the right command at the right time without looping, without repeating, without guessing. So what makes a top-performing AI in the terminal? It's not raw power. It's not verbosity. It's efficiency in both tokens and episodes. Top models. White heavy checkmark use fewer commands. White heavy checkmark generate less text. White heavy checkmark make fewer errors. White heavy checkmark solve tasks faster. They're not just trying. They're planning. They're reasoning. They're learning from mistakes, not repeating them. They don't type blindly. They think before they type. And the best part, the benchmark isn't just about doing tasks. It's about understanding them. Each task is pulled from real engineering workflows, not toy examples. Re-implement a legacy COBOL program in Python and match the output exactly. Debug a broken Docker container. Train a machine learning model from raw source code. Reverse engineer a binary file to extract its logic. The system doesn't care how you do it, just that you pass the tests. And the tests are real. They run in a clean, isolated environment. They check output behavior and correctness, not just syntax. This isn't just a lab experiment. This is the future of AI agents in real systems. Companies like Anthropic claim, their AI agents are driving $1 billion in revenue. Startups are building entire software teams powered by AI. But if those agents can't reliably handle a simple pip install, what happens when they're managing a server, a financial model, or a medical device? We can't trust AI to do high-stakes work unless we test it on real, hard tasks, not synthetic ones. Terminal Bench 2 is the first benchmark that actually does that. It's not easy. It's not clean. It's real-world, hard, and valuable. And the best part? It's open source. You can access it at T-Bench AI. Run your own tests. Build better agents. Push the frontier. So what's the big picture? AI agents are getting smarter. But they're not ready to replace humans, especially not in complex, real-world environments. Terminal Bench 2 isn't just a test. It's a wake-up call and a map for the future. It shows us where AI still stumbles and gives us the tools to fix it. Because the future of AI isn't about how many commands it can generate. It's about how well it can think, adapt, and deliver in the real world. And that's the real benchmark. If you found this fascinating, hit like, subscribe, and drop a comment. What task would you give an AI agent to solve? Let's see if it can handle it. Until next time, keep coding, keep questioning, and keep pushing the edge.